So if sine and cos functions get to have a graph, do tangent ones do? Well, yes they do, but they look very, very different. And so what we're going to do is we're going to, much like the other graphs, we're going to fill in a table of values and then start plotting away. And remember that tan is simply the y value divided by the x value, or the which is the sine value divided by the cos. So it would mean that for every pi on 2 or for every 90 degrees, it is undefined. So that's a pi on 2, that's a 3 pi on 2, and that is going to be undefined, and it's undefined. At the other extremes, they of course 0 divided by 1 or 0 divided by negative 1 is still 0, so that's 0, and that is 0, and that's 0 here. That's going to be 0 radians, that's going to be pi radians, and that is 2 pi radians. Now for the 45s, now that's using my right angle triangle here, 45, 45, 1, 1, root 2. So opposite over adjacent, 1 divided by 1, it is in fact 1. This is pi on 4, this is 3 pi on 4, that is 5 pi on 4, that is 7 pi on 4. So may as well start with our asymptotes. So at 90 and at 270. 90 and there's 270. And again, like all good labeling, we label these asymptotes, and x equals 90 degrees, x equals 270 degrees. At every, what's it, so at 0, 180, and 360, we get an x-intercept here. At every 45 degrees, which is about here, well, between 30 and 60, 225 is here, that'll be at 1, and then 315 is at -1. So what the graphs do is it actually looks something like this. Actually, I'll do this better. It actually looks something like this. So it looks like someone stretched out the sine and cos graphs. And yes, so there's no real point of inflection. The only things you really need to label here are the x-intercepts. And in a way, tan graphs are a little bit easier to draw. There's no amplitude for a start. So if you were to say that what's the amplitude of a tan graph, it's a false question. There is none. The only thing that will affect, and the period is slightly different calculation. Instead of 2 pi divided by n, it's equal to pi divided by n. Fun fact, every period's worth is equal to the x-intercept. So for instance, in this first one, the period is 3 is equal to 180 divided by n. So that's going to be, and n in this instance was 1. So at every 180 degrees or every pi, there was an x-intercept. But you'll see that when we get onto these things. So we've got tan 2x here. So the period is equal to pi over 2. Now the asymptotes are in between the x-intercepts. If you notice back in our original graph here, the asymptotes are actually exactly in between each of the x-intercepts, and the x-intercepts are equivalent to multiples of the period. So we want to draw it from pi to -pi, so let's go with, let's make that pi on 2, make this one, yeah, so that will become pi. The asymptotes, there'll be one at pi on 4, there'll be one at 3 pi on 4. Oh, the period is pi on 2, isn't it? Silly me. So that should be pi on 2. That'll be pi on 4. That's going to be pi on 8. And that's going to be 3 pi on 8. So we can put our asymptotes in. It'd help if I could do this in a straight line. That's straight enough. And So there we go. So we better fix up all the other ones as well on the other side, because we need to make sure we've got and there we go. So there's our tan graph. You'll notice there I've been not super accurate with where the 1 is, but that's okay. Don't need to really worry about that. Of course, you would label all of the coordinates in coordinate form there, but we have drawn tan 2x. Again, don't need to worry about that 3 at the front. It just means it's a little bit steeper, but you don't have to worry about amplitudes or things like that. The period is still pi, but we've just moved everything across. So the asymptote, so the x-intercepts are all moved across 1. So rather than being at, in this case for every pi, they've been nudged over to pi on 4. So normally our 2 x-intercepts would be here and here. But they've actually just been moved to the left by pi on 4. So we can actually, I'm going to use my pink here, that's the new ones. The asymptotes were originally, of course, halfway in between these. So they would have been at pi on 2. So pi on 2 is the same as saying 2 pi on 4. So they will also be moved to the left by pi on 4. So I'm going to use my orange to indicate it's been moved over. So it was originally, they were, if we hadn't done the translation, they'd be at 2 pi on 4. We moved them to the left by pi on 4. And so similarly, down here, it will be at -3 pi on 4. And then we're going to get my big old asymptotes in. Asymptote in, like so. So our graph should look something like this. So there we go. There it is. There we go. And then the last vestige of that would be about here. In fact, we probably could trim that to about here. We should always label our endpoints. So this would be at 310 pi plus pi on 4, 5 pi on 4. 5 pi on 4 is in the 3rd quadrant, so that's going to be at pi and 3 times 1, so that's pi 3. And so this is also going to be at -pi 3. And there you go. In fact, actually, that the y-intercept will be at the same place as well. So that'll be about here. So whoop, like that. And that'll be at 0, 3. There we go. So this tan graph has been moved over to the right by pi on 6. It's been dilated in all sorts of ways, and it's also been translated up by 1. It's moved over to the right by pi on 6. And so first things first, we need to worry about is the period. So the period is equal to pi divided by 2. So again, I'm just going to put a little thing here. So 0 pi on 2, that's where our x-intercepts would have been. There would have been a asymptote in between at pi on 4. But of course we've moved to the right by pi on 6, haven't we? So this now becomes pi on 6. So for the asymptote, we're moving from pi on 4 plus pi on 6. So that's going to be equal to 3 pi on 12 plus 2 pi on 12, making that 5 pi on 12. And then we've got pi on 2 plus another pi on 6, so that's going to make 4 pi on 6. Okay, so we're starting from the x-intercept, which is, and by x-intercept, actually, I should be reminding myself, everything's been moved up by 1. So actually, that pi on 6, that first point will be here. The other one will be at 4 pi on 6. 5 pi on 12 is the same as saying 2.5 pi over 6, so that's going to be about here. So I can put that asymptote in there. May as well get all of the other sort of essential points here. So they're all pi on 2 away. So pi on 6 take away pi on 2. I may as well get them. Stop saying pi on 2. They'll say the variations of pi on 6. So pi on 2 is the same as saying 3 pi on 6. So that's going to be pi on 6, or 1 6 take away 3 sixths. Going to make that 2 6 there, minus another 3 6, so it's going to be there. So, and 4 pi on 6 plus another 3 pi on 6, 7 pi on 6, that's fine. So it's not going to be there. So this one here, which is the 5 pi on 12, minus 6 pi on 12, it's going to make that here, so there is 1 there, minus another 5 pi on 12, sorry, another 6 pi on 12 is going to make that -7 or -3.5 pi on 12. There we go, so we can put our asymptotes in here. And what would be the y-intercept? So the y-intercept here would be at y equals 3 tan 2 negative, and again that should say pi on 6. Pi on 6 plus 1, so that's 3 tan negative pi on 3 plus 1. It's in the fourth quadrant, so it's going to be a negative answer. So pi on 3 is going to be 1 opposite over adjacent, so it's negative root 3. So that's going to be 3 times negative root 3 plus 1. So that's going to be negative 3 root 3 plus 1. So it's going to be something about here, I'd say. So we should get a graph looking something like that, looking like that, looking like, and it would end at the same point, so it's going to end there, and then I feel like there should be another asymptote over here. So 5 pi on 12 plus another 6 pi on 12 is 11 pi on 12. So it's actually, yeah, there is another asymptote in between here. There we go. 11 pi on 12, and then we would go and end to there. So our asymptotes are at x equals 5 pi on 12, x equals 11 pi on 12, negative x is equal to negative pi on 12, and negative 7 pi on 12. Is it? So it's negative 3.5. Yeah, so it should be 7 pi on 12, x equals 7 pi on 12. Yeah, there we go. And there is our asymptotes. I'll get rid of that dotted line because that was just a sort of a guidance mark.